Hi, my name is Roberto Gosman, and today I'm presenting my academic poster for my final project. The project's name is Low Cost Hand Tremor Activity Detector using an Arduino-based vibration sensor. So, for the abstract, first we have that tremors are involuntary muscle movements and they can indicate diseases such as Parkinson or essential tremors, but they can also happen only due to fatigue. Most devices to be able to detect this kind of diseases or detect the tremors themselves can be very expensive, which is why I decided to make an Arduino based tremor detector using a vibration sensor. And this device is able to detect activity through events per second. This device is very low in cost and it's an actual demonstration of how biomedical devices can work. For the objective, we have built a prototype that can record accurately the tremor events in someone's hand and demonstrate the differences between different conditions such as at rest, at hold, or shaking. Introduction and background. Tremors impact quality of life and daily activities for everyone who has them. And the detectors are actually very expensive and not accessible for many. So there are low cost sensors that can model the following, such as the vibration detection or event frequency, which is why I decided to use a 3-pin vibration sensor that works on a threshold based way to detect tremors whether they are present or not. Materials and methods. The materials I used was an Arduino Uno R4 Minima 3-pin vibration sensor, RGB LED module, passive buzzer module, breadboard and jumper wires, plus a USB cable and my computers. And the methods and wiring, you can clearly see there where every wire goes. Testing. So I tested for three different conditions. The baseline, which also works as a negative control, is just the resting the device on the table. At hold is holding hand with an extended arm, and shake, which is holding hand and simulate shaking. That means moving the device itself on purpose, which works as a positive control. From here, record events for 10 seconds, 3 trials per condition, and for validation, compare the average of 3 conditions, and what we expect is the baseline to be smaller than the hold and the hold to be smaller than shake. A prototype. Our Arduino program processes vibration events and computes an event with either positive or negative. So this records every 0.25 seconds for 10 seconds. So there are 40 possible events where shaking or tremor can be present or not. Assumptions. For this device, we have to make some assumptions, such that tremor intensity can be measured by event frequency rather than an analog amplitude, which would be a better way to measure, but with what we have, it works. And then external conditions such as posture or like sound within the environment remains stable for all trials for all conditions. So in our results, we clearly see that the rest condition had no events detected, the baseline condition basically. And you can see that clearly in the graph and in both graphs, actually figure 2 and figure 3, with the average events per second at 0 and no events counted throughout the 10 seconds. Then is the hold condition. There was a small increase in event frequency. So there's some slight tremor activity due to some muscle effort. The average was 0.04 for the hold condition events per second, and you can clearly see here how it increased through time. And then the shake condition had a very high tremor activity, which is 3.7 events per second. So there were still some parts where the sensor was not triggered, and you can clearly see the 3.7 right here in events per second and how it increased throughout time for the second graph. With this, we can conclude that the Arduino vibration sensor is able to successfully function as a detector throughout the prototype I built. The results were actually what we expected to receive based on the testing the expected. We received what we expected. Then it demonstrated an event-based detection, and it demonstrated that it's a pretty good way to detect something when analog is not possible. And the prototype functions as an accessible biomedical device since it's very low in cost. Then for future work, this project could be made better if if an analog accelerometer could be integrated to capture the amplitude of the tremors. This way, the real-time data could be logged through Bluetooth, and we could also develop a wristband so that the device can be more accessible for everyone instead of just holding it between fingers. I would like to acknowledge my instructors for their guidance. The final project guidelines they provided, Arduino Uno R4 Minima Kit, and the Arduino documentation for helping me throughout this project. Thank you.